Yep. May, June 2023, paper 4, variant 1. Yeah, question 1. A swimmer starts at point P and swims at a constant speed of 0.72 meters per second relative to the water and at right angles to the current. Determine the relative velocity. How can I find the relative velocity? If they're at right angles, then we can use the Pythagorean theorem to find the relative or the resultant velocity. How can I find the resultant velocity? He's kind of traveling upwards at a velocity of 0.72, and the current is moving to the right, to the left, I'm sorry, at 0.54. The resultant would be in this direction. How can I find it? Square root 0.72 squared plus 0.54 squared. Magnitude of the velocity is 0.9 meters per second. Can I find the direction? Yes. Usually, if he didn't state in which relative to the vertical or relative to the horizontal, then we'd usually find it relative to the horizontal by saying tan inverse y over x 0.72 over 0.54. Okay, tan inverse y over x. This is the more commonly used way of finding the direction. Okay, finding the angle. Tan inverse y over x. Okay, in this case, it's tan inverse 0.72 over 0.54, which is 53.1 or just 53 degrees. If he said relative to the vertical, okay, if he said relative to the vertical, it would have been tan inverse x over y. Can I find the distance between P and Q? Yes, I can find the distance between P and Q. Distance equals speed equals distance over time, so distance equals speed times time. Distance equals speed times time. Speed is 0.9 and the time is 1.5 minutes. We need to convert the minutes to seconds. This would be 90 seconds. So 0.9 times 90 is 81 meters per second. When the swimmer is crossing the river, his actions produce a constant forward force on his body. Explain why he moves at a constant speed. Constant speed. He has a forward force. Therefore, uh, there must be a resistive force. So you have to say that the resistive forces hmm, is equal to the forward force. Zero resultant force. Okay, zero resultant force, zero acceleration. This is what we mean by a constant speed. Okay. Hmm. Okay, motorcyclist accelerating. Can I find the speed at the end of the straight section? He has an acceleration of 7.2. He accelerates from rest. Accelerating from rest meaning that u is 0 and you have the time 5.3 seconds. So can I find the speed or the final speed, final velocity? Yes, a equals v minus u over t in which u is 0. So to find the velocity, all you need to do is multiply the t by the a. So v equals a times t. 7.2 times 5.3. 7.2 times 5.3 is around is 38 meters per second. Can I find the resultant force? Yes, I can find the resultant force. F equals ma. F equals ma. 240 times 7.2. F equals ma, which is 240 times 7.2, 1000, around 1700 newtons. Velocity is a vector quantity. State how vector quantity differs from a scalar quantity. Vector has a magnitude and a direction, while the scalar has a magnitude only. Describe what happens to the velocity of the motorcyclist as she travels around the bend. As she travels around the bend, what happens? The velocity changes. Why? Because the direction changes. Okay, velocity changes as the direction changes. Explain why there must be a resultant force on the motorcyclist as she travels around the bend. Why must there be a resultant force? As she's traveling in a circular motion, kind of circular motion through the bend, isn't there a type of acceleration, a type of force, which is called what? Change, which is called a centripetal force. There is a centripetal force which is perpendicular to her direction of motion. Uh, There is a centripetal force. So as this force acts on her, she's accelerating, she's changing her momentum, she's changing her velocity. So, centripetal force acts on her, changes. Okay, she changes her velocity, acceleration, momentum as she's going through this curve. Okay, a rubber balloon is inflated with helium and sealed so that no helium escapes. The balloon is positioned immediately below a ceiling room in a room. When the heaters are first switched on, the temperature of the air immediately below the ceiling increases more quickly. Why is that so? As you immediately switch on the heater, the temperature rises. Temperature of the air near the ceiling rises. Why is that? It's due to convection. Due to convection. Why? Because the convection, as as the temperature increases, the density of hot air decreases. So hot air rises up and cold air falls down. The temperature of the helium inside the balloon increases and the rubber stretches. The volume occupied by the helium increases. State what happens to the motion of the helium particles as the temperature increases. What happens to the motion of the helium when the temperature increases? What happens? You can say that as the temperature increases, the kinetic energy increases. They move faster. Kinetic energy increases. Hmm, They move faster. They move faster. They move faster. As the rubber stretches and the volume of the helium increases, the pressure of the helium remains constant. Pressure of the helium remains constant. Explain in terms of particles of helium how the pressure of the helium remains constant. As the volume increases, as the volume increases, the pressure should decrease, shouldn't it? Yes, it should. And as the temperature increases, the pressure should increase. Yes, it should. But how does the pressure remain constant as the temperature increases and as the volume increases? We need to state in terms of particles that initially, as the temperature increases, the particles hit the walls faster and harder. They hit the walls faster and harder as temperature increases. Molecules hit the walls faster and harder, increasing the pressure, initially increasing the pressure, initially increasing the pressure. As the pressure initially increases, what happens to the volume? It's a balloon. It's a balloon. When the volume increases, as the volume increases, okay, as the volume increases, what happens to the pressure? The pressure decreases. The pressure decreases. So they kind of cancel out. Okay, the pressure increase cancels out with the pressure decrease. Okay, canceling out the initial pressure increase. So kind of, you might say initially it increased by, let's say, 10,000 pascals, and then it decreased by 10,000 pascals, or whatever. Okay. Okay. Next question. We have a student investigates the efficiency of a filament lamp. Filament lamp efficiency, and he immersed this filament lamp in a beaker of water. The reading on the thermometer in the water is 19 degrees Celsius. So we put the lamp inside the water, and the reading of this water is now what is 19 degrees Celsius. On the glass, only the glass of the lamp is in contact with water. Okay, so no electrocution. He will not be electrocuted, so don't worry about it. The lamp is switched on. Lamp is switched on. At the end of the experiment, the temperature of the water is 21.5 degrees Celsius. 21.5 degrees Celsius. What happened to the water? The temperature of the water has increased. The temperature of the water has increased. Can I show that the temperature, or that the energy supplied to the water, the energy supplied to the water is 6,300 joules? Yes, I think I can. Why? Because I have the temperature difference, I have the mass, I have the specific heat capacity. So basically, E equals mc delta T. E equals mc delta T. The mass is 600. In this question, you cannot leave it as 600. You need to convert it to kilograms. So it would be 0.6 kilograms. Why? Because the specific heat capacity is in kilograms degrees Celsius. So 0.6 times 4,200 times the increase, or the change in temperature, which was 21.5 minus 19. So 0.6 times 4,200 times 2.5 is exactly 6,300 joules. Three very easy marks. In the experiment, the lamp is switched on for 500 seconds. The power supplied to the filament lamp is 13 watts. You have the time, you have the power. I think we can find the energy. The useful think about it. The useful energy from the lamp is transferred as light. The useful energy transferred is light, which is quite obvious. We use lamps for lighting. I think this is quite obvious. The energy that increases the temperature is wasted energy. So now he has stated very clearly the difference between the useful energy and the wasted energy. Okay. Determine the maximum possible efficiency. Okay. Can I find the energy input? First of all, can I find the energy input to the lamp? Yes, because I have the power and I have the time. So basically, the energy input of the lamp is power times time, which is 13 times 500. This would give you a energy input of 6,500 joules. Okay, good. And the efficiency, we know that the efficiency is the useful power output. Useful output over the total input. And if for any reason you do not know the difference between the output and the input, okay, usually, not usually, most definitely, the input will always be greater than the output. The input will always be greater than the output. So we have the input, which is 6,500 joules. This is the total input. The useful output in this case, he said that the energy used to heat up the water, the energy used to heat up the water was the wasted energy. Can I find the useful energy? Yes. 6,500 minus 6,300, which is 200 joules. 200 Joules. So this is the useful input. This is the light energy. This is the light energy. Because the light energy and the heat energy have to be equal to the total input energy, which is 6,500. So 200 divided by 6,500 is, I guess, 3%. If you multiply by 100, it would be around 3% or 3.1%. Okay, if you multiply by 100, about 3.1%. The efficiency of the lamp is less than the value determined. Why is that? Why is the energy, or why is the efficiency less? Because some of the energy is transferred, some of the energy is lost to the environment. Some of the energy is lost to the environment. Hmm. Okay, yeah. Figure 5.1 shows a block ABCD made of glass that has a refractive index of 1.5. The block has one curved side AB. Okay. There are right angles at C and D. Okay. The curved side AB is 1/4 of the circumference. Is 1/4 of the circumference of the circle that has center point at P. Okay, ماشي. Has center point at P. Array of monochromatic light enters the light. What does monochromatic mean? What does mono? One. Mono, one. Single or one frequency. One frequency, one wavelength, one color. One frequency, one wavelength, and one color. Mono. Explain why the ray of light does not change direction as it enters through side AB. As it enters through side AB, the angle of incidence is what? Angle of incidence is zero. Angle of incidence is zero. Why? Because and angle of refraction is also zero. Why? Because it's perpendicular to the surface. Okay, it is perpendicular to the surface. You can say it's kind of um, moving along the normal line. So angle of incidence is zero, and angle of refraction is also zero. Hmm. Show that the critical angle for glass of refractive index 1.5 is 4.42. Can I find the critical angle? Yes, we have an equation. N equals 1 over sine C. To find C, to find the critical angle, C would be equal to sine inverse 1 over N. Sine inverse 1 over 1.5, which would be around 41.8 degrees, which is very close to 42. Okay. Figure 5.1 shows the angle between the ray of light and line AP, where AP is the right angles. Angle theta is increased to 45 degrees. As you increase the angle to 45 degrees, what happens to the light that strikes P? This angle theta would now increase to 45 degrees. What would happen? 45 is greater than the critical angle. Isn't the critical angle 42? Yes, so 45 is greater than 42. The phenomenon is called what? It's called the total internal reflection. Total internal reflection. Total internal reflection. In which all of the light is reflected back inside the medium, and this happens when the angle of incidence is greater. You have to state that it's greater than the critical angle. And the angle of incidence is greater than the critical angle. Okay. When theta equals 45, the reflected light strikes CD. Reflected light strikes CD. Describe what happens when the reflected light strikes CD. Okay. When theta is 45. When theta is 45. Let's go back to the diagram. As theta is 45, it would strike BC at an angle of, it would totally internal reflect at an angle of what? At an angle of 45. So it kind of would move this way at an angle of 45. When it reaches this side, when it reaches this side, if you think about it, 45, 90, then this angle would also be 45. So it needs to go back, okay, reflect back at an angle of 45. Okay, light is reflected back at the same angle. Okay, total internal reflection again. Total internal reflection at the same angle again. Total internal reflection at the same angle of 45 degrees. Hmm. Can I find the wavelength of microwaves? Yes, I can find the wavelength of microwaves. You have the speed, you have the frequency, so wavelength equals speed over frequency. 3 times 10 to the power of 8 over frequency, 1.9 to the power of 9, which is around 0.16 meters. State two reasons why microwaves are used in mobile phones. You have two main reasons. One of them is because they can go through walls. Okay, they can penetrate if you penetrate walls, and then they have mobile phones. More recent mobile phones have very short antennas. Okay, have very short antennas. Can go through walls and have very short antennas. A mobile phone uses a digital signal. Describe with the aid of a diagram how digital signal differs from an analog signal. A digital signal is either 1 or 0. 1, 0, 1, 0, 1, 0. This is a digital signal, so it's either 1, okay, or 0. But an analog signal can vary continuously between two numbers, okay? This is an analog signal. Digital only values of 1 or 0. You can say on or off, high or low. That's it. Digital signal, it's black or white. That's it. But analog, it can vary. Okay, it can vary between two. Okay, between two values. Okay, between a high value and the low value. Okay, can vary between a range of values. State two advantages of using digital signals. Actually, we have three advantages of using digital signals. Okay, three advantages. We can remove the noise. We can remove the noise on the signal. We can transfer this data at a faster rate. Okay, and we can transfer this data over longer transmission. So we can easily remove the noise on the signal, faster rate of transmission, faster rate of transmission, and you can say over longer distances. Longer distances. Okay. Figure 7.1 shows a circuit that contains a battery, switch, a voltmeter, and a 40 ohm resistors R1, 2, and 3. They're all 40 ohms. The switch is open. Switch is open, so only 1 and 2 are on. Only 1 and 2 are on. What does he mean by a potential divider? Potential divider. Basically, I'm dividing. Divider. I'm dividing what? Dividing the total voltage. I'm dividing the total voltage of this power supply between different components. Okay, I'm dividing the total voltage of the power supply between different components. The reading on the voltmeter is 7.5. Find the electromotive force of the battery. So this is 7.5 volts. The resistance of the first resistor was 40 ohms, and the resistance of the second resistor was also 40 ohms. The whole point of a potential divider is if the resistance is equal, then the voltage is also equal. If the resistance is equal, then the voltage is also equal. So basically, you might say 40 ohms and 40 ohms, so 7.5, and this one would also be 7.5 volts. So the total voltage of this battery would be 15 volts. That's it. Total voltage would be 15 volts. The switch is now closed. Can I find the total resistance of this circuit? Yes, I can find the total resistance of the circuit. This resistor is 40 ohms. So you have two resistors in parallel. They're both equal, so the total resistance of them would be 20. As a rule of thumb, you can say if you have two equal resistors in parallel, then the total resistance would be half of them, half of one of them. Total resistance would be 20. But you can use the rule which is product over sum. You can use the rule product over sum, which is 40 times 40 over 40 plus 40, which would give you a total resistance of 20 ohms. And then you need to add the resistor 1, which is 40 ohms, which has a, so the total resistance of this circuit would be 60 ohms. Total resistance would be 60 ohms. Can I find the reading on the voltmeter when the switch is closed? Can you find the reading when the switch is closed? Yes. Okay, some of you might say V equals IR, which is not wrong. It's not wrong to say V equals IR. To find the total current, you'd say I equals V over R. V over R. So 15 over 60, which is 0.25 amperes. This is the total current. And then you might say, so it's V equals IR. V equals IR. I is 0.25, and the resistance of this resistor is 40. 0.25 is 40. So 10 volts. It's not wrong. Okay, it's not wrong. You can use this way. The voltage would be 10 volts, yes. Or you can use another way, which is using the potential divider. What do I mean by using the potential divider? Potential divider basically states that the voltage is divided equally using a ratio. Using a ratio. If the total voltage was 15 volts and the total resistance was 60 ohms, let me write it down here. If the total voltage was 15 volts and the total resistance was 60 ohms, the resistance of this specific resistor is what? Is 40 ohms. Can I cross multiply? I guess I can. So cross multiplication, 40 times 15 divided by 60. 40 times 15 divided by 60 would also give you a reading of 10 volts. So you can use either way. You can use this one or the other one. This might be a bit easier if the numbers were much harder, much more difficult. You can have much more difficult numbers. Okay. The electricity supplied to a town is transmitted using a high voltage cable. A transformer has a soft iron core. Explain the principle of operation of a simple iron core transformer. Okay, iron core transformer. Basically, if we talk about the transformer, we need to state that the input current is an alternating current, creating an alternating magnetic field that cuts the secondary coil, producing an alternating induced magnetic field. That's it. That's it. So the primary coil Let's say, yeah, the primary coil has an alternating current which produces an alternating magnetic field which cuts, you have to say it's cutting, which cuts the secondary coil, producing an alternating, an alternating induced EMF, EMF and current. Okay? Hmm. Not too difficult, is it? Nope. The transformer steps the supply voltage down, step down from 220,000 to 33,000. There are 450 turns on the secondary coil, which is VS. NS. This is the secondary coil, so this is NS. So basically, we have VP, we have VS, and we have NS. We need NP. VP over NP equals VS over NS. 220,000 divided by NP equals 33,000 divided by 450. Cross multiply 450 times 220,000 divided by 33,000. This will give you a total number of 3,000. 3,000 turns. The electrical power transfer to the transformer by a voltage is 77 MW. What does capital MW mean? Megawatts. Mega is times 10 to the power of 6. Can I find the current? Yes, power equals VI. Power equals VI. So I equals P over V. Power is 77 times 10 to the power of 6 divided by the current, divided by the voltage in the primary coil, which was 220,000. 220,000, which is a huge current. 350 amperes. 350 amperes. Okay. Figure 9.1 represents all of the particles in a neutral atom. A neutral atom. What are the number of neutrons in this neutral atom? And explain. Explain. Number of neutrons. Should I count the white or the gray ones? Should I count the white or the gray ones? Definitely we should count the gray ones. Why? This is the explanation. This is the explanation. This is a neutral atom, therefore the number of electrons have to be equal to the number of protons. Okay, so we have 5 electrons and we have 5 protons. So basically we have 7 neutrons. You have 7 neutrons in the nucleus. Isotope X1. I think this is X1. Yeah. Isotope X1 decays by producing a beta particle. How the nucleus of X2 is different than the nucleus of X1? How is it different than X1? As it produces a beta particle, what happens to the number of protons? The number of protons increases by 1. Okay, proton number increases by 1. So proton number is equal to, protons are now equal to 6. What about the number of neutrons? Number of neutrons is now also equal to 6. So just why isotope X2 is stable whereas X1 is not stable. X2 is stable while X1 is not stable. To create an unstable isotope, you need to increase the number of neutrons. Again, to create an unstable isotope, you need to what? You need to increase the number of neutrons. So X1 has more neutrons than X2. X1 had more neutrons than X2, and that's why X1 was not stable. So why is X2 stable? Because it has less neutrons. It has less neutrons. Define the term half-life. 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 It's the time. It's the time taken. For what? Hmm. For the amount of decay to decrease to half the previous amount. Okay, the time taken for the decay or the radiation or whatever to decrease to half the previous amount. So just one reason why isotopes with very short half-lives are especially hazardous. Very short half-lives are very hazardous. He said that the half-life is 20 milliseconds. 20 milliseconds. So in 1 second, you'd have 5 half-lives. In 1 second, in 10 seconds. The more the half-lives, the more amount of radiation, okay? The more amount of radiation is produced. So very, very large amount of radiation is produced in a short time. Large amounts of radiation produced in a short time. Okay, Pluto, I know it's a dwarf planet, but it still kind of rotates around the sun. It's still considered to be part of our solar system. It's a dwarf planet, but it's part of our solar system. Point X is the point closest to the sun, and Y is the furthest away. Describe how the speed of Pluto varies as it moves from X to Y and back to X. From X to Y, X to Y. What happens to speed? Speed decreases. But Y to X, what happens to speed? Speed increases. Why? In terms of energy. In terms of energy. As it moves from X to Y, what happens to the as it moves from X to Y? What happens to the kinetic energy? Kinetic energy decreases. But it's transferred to what? To gravitational potential energy. From X to Y, kinetic energy decreases and gravitational potential energy increases. From Y to X, you'd say that the kinetic energy, okay, kinetic energy increases and the gravitational potential energy decreases. So the high, highest or the largest amount of gravitational potential energy is at Y, and the highest kinetic energy is at X. That's it. Hmm. The temperature on Pluto is 43 Kelvin. Kelvin. Yeah, can I find the temperature in degrees Celsius? Yes, I can find the temperature in degrees Celsius. Kelvin equals, or Celsius in this case, we can find Celsius is Kelvin minus 273. 43 minus 273 is 230, negative 230 degrees Celsius. Pluto has a white surface as shown. As Pluto rotates, the white surface alternately faces towards and away from the sun. Towards and away from the sun. Explain how this affects the temperature of Pluto as it rotates on its own axis. It's rotating on its own axis. As it's rotating on its own axis, what happens? White. So it's a white color. Is it a good or poor absorber of infrared radiation? Hmm. Definitely, it's a poor absorber. It's a bad absorber of infrared radiation. So when the white surface is facing the sun, Temperature would increase, but would it increase as much as if it was the black surface facing the sun? Hmm? No, no. So you need to say that the white surface is a bad or a poor absorber of infrared radiation, That's why you have to say a temperature increase wouldn't be as much. A temperature increase wouldn't be as much as the black surface. Okay, would be less. Let's say would be less. Would be less.